Hello everyone, welcome to the channel today. Today we want to solve circular measure questions, okay, that have come in the exam. This set of questions is from 2021 backwards to about 2019, okay. So I have compiled this worksheet for you. And I'm going to solve as many as I can, okay, within 1 hour. If it is more than 1 hour, I'll stop. But the worksheet, I'll put a link in the description below so you can just go there, download it, and work alongside with me. And I've kept the year beneath each question so you would know the year that came. Check the marking scheme when you are done solving it, okay? So I'm going to give you all the tricks that you need to work with circular measure, all right? And then at this stage, if you haven't subscribed, then please subscribe to the channel. Well, YouTube tells me that about 85% of people who watch my content are actually not my subscribers. So why not subscribe to help me as I also help you? Right, so let's start with our first question. This question says that, okay, the most important thing about this circular measure thing, okay, is the description that they gave. All right, this whole thing here, you have to read it. That is where all the clues are. All right, so we are told that let me clean it and then we can look at it. We are told that AOB is a sector of a circle with center O, okay, and radius is 16, and then the angle AOB is 2 pi over 7 radians, and then point C lies on OB such that OC is 7.5 and AC is a straight line. Okay, remember that if AOB is a sector and OA is a radius of 16, therefore OB should also be a radius of 16, okay? But if OC is 7.5, then the remaining to make it 16 should be 8.5, right? Yeah. Okay. Then it means that we are, this whole analysis was done from the preamble. I haven't even read the question. I don't even know what the question wants me to do, okay? But I know that I can fill in the missing parts, okay? So that's what you should do. Now, before we actually answer the question, when it comes to radian measure, there are a few formulas that we need to remind ourselves, okay? First formula is arc length. You will see lots of radian measure questions that you will have to use the arc length. So arc length is r theta, where r is radius and theta is the angle under discussion, okay? Then you would also work with area of a sector, so I'll call it sector area. The formula is half r square theta, okay? And then the last thing that you will work with is area of a triangle, all right? Area of a triangle, or you can just call it triangle area. That formula is, let's say I have let's say I can draw this line, okay, to block it like that. So I have triangle AOB, right? If I want to find it, and this is radius, that is radius, then I can say that it is half, okay, r squared, all right? Remember, it's half AB sine theta. So sine the angle in between it, okay? And AB are the sides, so I can just write half OB OA sine the angle between them, right? But since they are both radii, then I can say that half r squared sine the angle between them, okay? So this is the concept that you are going to use throughout circular measure, so keep it in mind. These three formulae are all that you need, nothing else, okay? No other formula would you use in our discussion. All right, so the question says that we should find the perimeter, okay? The perimeter of the shaded region. Well, there's always a plan, okay? Okay, so the plan is that if I know the arc length AB and I also know the side AC, I can add it to the 8.5. Then I have found the perimeter of the shaded region. So that's the plan. So let's start with the arc length. Since we know the angle, so we can start with arc length. Arc length will be equal to r theta, right? radius is 16, and then the angle is 2 pi over 7 radians. Now at this stage, my friends, I'll tell you to change your calculator from degrees to radians if you haven't done so. Okay, that is very important, because if the measurements are in radians and then you use degrees to work, unfortunately you've used a different measurement, so you'll get 0. That's the unfortunate thing, but I mean, it happens. So please check your calculator before you start answering questions on radian measure. All right, so that is 16 into bracket 2 pi 2 pi over 7, right? Yeah, sure. So well, we can just write 32. I don't want to write the decimal, so let's write 32 pi over 7. That's cool. Then the next thing that we need is what? AC, right? So if you want to find the measure for AC, okay, you can use the cosine rule. So you have AC is equal to the square root, okay, of 16 square plus 7.5 square minus 216 7.5 cos the angle, which is 2 pi over 7, okay? And then we put this on the calculator. So we have the square root of 16 square plus 7.5 square minus 2 into bracket 16, and then 7.5 cos 2 pi on 7. Right, so according to my calculator, I should get 12.75, okay? Then the last thing that you want to do, you know, we have found, these are the things that we've done. We have found the arc length, we have found the AC, so we just have to add it to BC, and then we are done. Okay, so to answer the question says perimeter of the shaded region, right? So let me clean this more. Then we can use maybe black. So perimeter will be equal to 32 pi on 7 plus 12.75 plus 8.5, and that will give us, so plus 8.5 plus 32 pi over 7, and that should give us 35.6, okay? 3 significant figures, and then you are done. Well, the B part says that find the area of the shaded region. Well, so we need a plan. Okay, so if you want to find the area of the shaded region, we can find the area of this sector, okay? After that, we can find the area of the triangle. Then we can subtract the area of the triangle from the area of the sector. Then we have the shaded region. So that is the plan that I want to use. Of course, you are at liberty to use any other plan that you have, but I think this will be easier, okay? So first, area of the sector. So let's find sector area. So sector area will be equal to sector area, that is half r squared theta, right? So half, the radius is 16 square, and then the angle there is 2 pi on 7, 2 pi on 7, okay? So this will be 0.5 times 16 square times 2 pi on 7. Calculator says you get 256 pi on 7, okay? Then you find the triangle area, okay? So then, can I call it triangle area? Yeah, probably. Triangle area will be equal to half 16 times 7.5, okay? This is what you are doing. Half this side times that side times sine of the angle in between them. Okay, so that's what we are doing. So times sine 2 pi over 7. Okay, so that means that we have 0.5 times 16 times 7.5. Okay, sine the angle, which is 2 pi on 7, right? So that gives us 46.91. Okay, so now let's subtract and then find the shaded region. So area of the shaded will be equal to, like I said, the sector area over 7, okay, minus the triangle area. So that is 256 pi over 7 minus answer, giving us 67.98. So roughly I can say that we'll get like 68, okay, correct to 3 significant figures. That is cool. So that's how to go about questions like this, okay? Let's move on. So this is actually, if you look at it carefully here, you see the date. This is February 22, okay, February, March 22. Question, which is the year? 21, okay, this current year. All right. Now, the next question says that a circle has a radius of 6. A sector of this circle has a perimeter of that. You should find the area. So it's like they gave you a radius, they gave you a sector with a perimeter, and then they want you to find the area. Okay. Now, don't be scared. First, ask yourself, what is the area of a sector? So sector area is equal to half r squared theta. Okay, so all that you need is radius. If you can find the radius and then the angle, you are good to go. Well, the question gave you the radius. So what is the next thing left? Is the angle. If you know the angle, you are good to go. Okay, so let's go and look for the angle somewhere and then come back. Well, we can find the angle from what they have given us. They said that the sector has a perimeter of 2 into bracket 6 plus 5 pi, right? So if, for example, if this is the sector that we are talking about, oh, it's so terrible. For your information, I'm terrible when it comes to drawing, okay? So if the radius is 6, okay, and this will also be 6, okay, we do, let's call this theta, so that the arc length is r theta, but the radius is 6, so the arc length will be 6 theta, right? Now, they are saying that the perimeter is what they have given us, 2 into bracket 6 plus 5 pi, okay? So now, what is the perimeter of this sector that we have written? That's 6 plus 6 plus 6 pi, okay? We can equate this perimeter to the perimeter that is given in the question, okay? So now we have 12 plus 6 pi is equal to 2 into bracket 6 plus 5 pi. You can factor out, or you can just divide through by 2, so that you have 6 plus 3 pi is equal to 6 plus 5 pi. All right, and that will give you the 6 will cancel out with the 6, because this and that will be 0. And then what are we looking for? We are looking for the theta, so theta will be equal to 5 pi over 3. Okay, once you have found the theta, you know the radius, so bam, you can solve the question. Let's do it. So we have half, the radius is 6 square, and the angle is 5 pi on 3. So now you can just put everything on calculator and we're good to go. So 0.5 times 6 square, which is 36, times 5 pi over 3, and that gives you 30 pi, which is 94.2. Okay, 3 significant figures. So that is how to go about it. You get you get the sector yourself. They say radius is 6, so you use all the things that you know, and then the keyword that they gave was the perimeter of that, and then you are good to go. So you see, it's not difficult at all. All right. So I need you to breathe in the exam room, okay? Relax, and then analyze the questions and solve it. You'll be fine. All right. The B part says that, like I told you earlier, the English that they have written here is really important. So let's read it. It says that the diagram shows the sector AOB of a circle with center O and a radius of what, 7. What else do we need? They have given us that OAB is pi on 4, so we should find the perimeter of the shaded region. Okay, if OA is a radius, then OB is also a radius of 7. Okay, so to find the perimeter, if we know this length, we can find the arc length, and then we add this to that, and then we are done. Okay, they want the perimeter of the shaded region. So that's the plan that I'm going to use. Therefore, let me find the length AB. Length AB is the square root, okay, of 7 square plus 7 square. I'm actually using the cosine rule, okay, minus 2 into bracket 7 into 7 cos the angle between them. Okay, let's put that on the calculator. Make sure you are working in radians, okay? Put the calculator's mode to radians. If the calculator is not in radians, you are going to get different answers, and my friend, that would be bad for business, okay? It will be so sad that you know what you are doing, but your calculator is in the wrong mode. So this should give us 5, according to my calculator, 5.3576, okay, something like that. All right, then I also need the arc length. So arc length, what name will we call the arc length? AB? Yeah, arc length AB will be equal to r theta, right? So 7 into pi on 4, and that will give us, can I just write 7 pi on 4? Yeah, so that I can just add the 2 and say that the perimeter will be equal to 7 pi on 4 plus 5.3576. Now you'll be wondering why I wrote that in 4 decimal places. Why I wrote it in 4 decimal places because I'm going to use it to further solve a question, okay? So I don't want to start approximating and then my final value will change from what Cambridge will use. So I'm looking at 10.855, so that's 10.9 correct to 3 significant figures. So this is how to go about it. You just find the the length AB, and then from there you find the arc length, and then you are good to go. Okay. All right. So this was a paper in February 2020. This is paper 2.2. Right. Now at a glance, you look at a question like this, you are like, oh God, this is going to be difficult, right? That's not difficult. Let's see. You read a preamble, you get more information from the preamble, and then you can solve it. So always don't just jump into the question, read from the preamble. While you are reading from the preamble, if you find something useful, start indicating on the question paper, okay? So the diagram shows a company logo, ABC, D. The logo is part of a sector. Well, they have mentioned a sector. Don't we know what a sector is? We know the formula for the area of a sector. We know the formula for arc length. So no problem. Okay, let's continue. With center O, great, and a radius of what? 50. Now we know the radius. What do they want? Point C and D, they lie on OB and OA respectively. So D is here, C is there, they lie on that line. Cool, no problem. What else? The lengths AD and BC are equal. That is very important. So if this is 1,000, okay, this will be 1,000. That is really, really important. All right. So I'm going to highlight that in a different color. All right, because it's going to really help us now work out maybe probably blue. Okay, very, very important. So like I said, all these things, you get it from the preamble. So if you don't read from the preamble, you are in trouble, friends. Okay, now this is also very, very important. They are saying that AD the ratio of AD to AO is 7:10. Now let me explain what that means. Look at OA. OA is the entire thing, okay, from here all the way to here. And they said that AD is to AO is 7:10, right? So that means that OA or AO has been divided into 7 parts, okay? Now, into 10 parts. What is the length of AO? Well, AO is a radius, so the whole thing should be 50. But if you divide 50 into 10, then each part is what? Yeah, 5, right? So each part is 5. Now they are saying that from A to D, take 7 of the 5s. So 7 times 5 is what? 35. That makes this 15. Now they said that AD is equal to BC, so this is also 15. This is 35. That makes OC what? 15. So you see, I got all these from the preamble. Okay? All right. Then the next thing that they gave us the angle. Okay? They said that the angle is 4 pi on 9. Great. What do they want? They want us to find the perimeter of ABCD. Okay? So that means we are going A to B to C to D. It is the perimeter of the shaded region. That's what they want. We know AD, we know BC. We can find DC by using the cosine rule, and then we will use the formula for arc length to find the arc length AB. Then we can add them up and we are done. You see, analysis. This is all that you have to do. So take your time in the exam room and analyze. So where do we start from? Maybe we can start from the arc length AB. So arc length AB will be equal to the radius is 50, and then the angle is 4 pi on 9. So that will be 5 times 4 is 20, so 200 pi on 9. Let me hold on like that. I don't want to write decimal for now. Then since we know we are left with what DC, so DC, use the cosine rule to find the length DC. DC will be 15 square plus 15 square minus 2 into brackets 15 into 15 cos the angle in between them, which is 4 pi over 9. All right, and that will be this one. I don't think any of us can get it off head, so we got to use the calculator to do that, unless you are Archimedes or any of the great mathematicians who ever lived. Okay, I don't even think they can do it off head. So you get 19.3. Okay, let me just write about 4 decimal places. 19.2836. Okay, so this is what you have. Now they want a perimeter, right? Now, so we are going to add this to what we have found, 19 point something. So let me just write 19.3. Then we add it to 35. Then we add to the arc length, which we got 200 pi on 9. Great. And then we are done. Okay, so that's what you're going to do. So the perimeter is going to be 200 pi on 9 plus 19.2836 plus 35 plus 35. Okay, we are done. I hope I captured everything. Yeah, I did. So let's add them up. Okay, add them up. Great. So according to my calculator, I have 159.1. Okay, I could be wrong. Why not? I mean, check it out. When it comes to addition and these things, no one is a genius. You could get it wrong. So please double check my answers, okay? That's why I want you to download the worksheet and work with me. Don't just look at me. All right, so the next thing is we want to find the area of ABCD. Okay, area of the shaded region. Okay, that too, we need a plan. But what is the plan? If you want the area of this shaded region, we can find the area of the sector, and then we find the area of the triangle, and then you subtract. You are done, okay? So you can even write the plan down that area A, B, C, D will be equal to sector area minus triangle area, okay? That's your plan. Cool. So let's start with sector area. So sector or sectorial area, some people call it sector area, others say sectorial area. I don't know. You guys are the English people. So that would be, remember the formula for this thing is half r squared, right? And r is 50. So we have 50 square, half r squared theta, and theta is 4 pi over 9. So that will be 0.5 times 50 squared times 4 pi over 9. That will give me 5,000 pi over 9. Okay, now let me go and do area of triangle. Area of triangle, that will be half the side times the side, okay? And each side is 15 if I remember correctly. Yeah, each side is 15, so half times half, half 15 times 15, then sine the angle that was given, which is 4 pi on 9, and then according to the calculator we will get 0.5 times 15 times 15 times sine 4 pi on 9. Then we add them up, we get 110.790873. Okay, I read the whole thing, don't mind me. Okay, so area A, B, C, D is going to be 5,000 pi over 9 minus 110.790873. This would give us, so 5,000 pi over 9 minus my answer, that should give me 1634.5. Okay, so this is definitely going to be the area of the shaded region, okay? So that is basically the plan, and you realize that it's something that Cambridge has been doing, okay? Let's take a minute and then check this one out. The first question, they gave us a sector, and then we can find a triangle in it, okay? Now the second question, we also saw a sector, and then there's a triangle in it. The third question, a sector, a triangle in it. So this is something that Cambridge has been doing. Whenever they give you a sector question, there may be a triangle in it. So, and you know how to go about these things, okay? It could be full sector question, no triangle, maybe a circle that is found in it. I mean, there are a lot of things that they do, okay? But I mean, this is something that you know. Okay, so you see, I'm not actually going to solve this question because this question is really similar to what we've been doing, okay? So I'll let this one go. It's a paper from May, June 2020, so you can check it out later on, okay? Solve it, check the marking scheme is correct, come and comment down there so I'll know that you guys are doing the work and then you are getting it, okay? But this one, I'm going to solve it. I'm going to solve it because there's a keyword here that I need to help you to see, okay? It is really similar to the question I want you to do, just that if you consider this one is just like this, and here it touches it here. So that's the difference, okay? And this one, I know you can solve it easily, all right? Because if this whole thing is 12 and this is 10, then it means this is 2, okay? So I just identify the parts and then you keep moving and you are done. So that's cool. Let's come here. This is where the interesting thing is. This question says that the diagram shows an isosceles triangle. Once you are saying that it's an isosceles, pay attention to the two parts that are equal. They say that OA is equal to OB. Okay, so if OA is X, then OB will also be X, right? Because it's what? An isosceles. Okay, then they told us that the angle AOB B is theta. So I mean, they have indicated that there should be school. The points C and D, they lie on OA and OB respectively, and that's true. C is here, D is here, that's cool. CD is an arc length of 9.6. That is very, very important. They gave it that to us, so we don't have to highlight it. And then they said that the center is O, obviously, and the radius of this arc, okay, of this sector is 12. Not OA, which is 12. No, it is the radius, okay? Now, this is the most important part of this argument. The arc CD touches the arc length. That is what you must decode in order to solve this question. If you don't understand that, maybe you can solve it, but you really suffer in the exam room. And who has the time to be doing try and error? Okay. So what do you need to know? Right. The fact that, okay, CD touches this means that from O all the way to M is also a radius. True or false? And it's true, right? It's a radius. It's a radius of 12. Okay? Because the shape OCD is actually a sector. Okay, so the fact that it's touching AB even makes it easier for us. Why? Because we can get a right angle triangle. Well, when we have right angle triangle, we get to do a lot of things. We can use a lot of trig ratios here. Okay, so you take your time. What is the first question? Find the value of theta. They want us to find theta. How do we do that? Okay, let's see. You have two parts. Let me extract the triangle. Let's say triangle AOM. Okay, if I extract this triangle, AM is here and then O is there. Now this is the angle I'm looking for. Okay, if I find it, I'll multiply by 2 so that I know the whole of theta. Now this is 12, this is 12, so I can use let me call this the angle X. So adjacent hypotenuse, right? And that means that we are dealing with, let me see, so ka twa adjacent hypotenuse cos. So I can say that cos X is equal to 12 over 12. So X will be equal to the cos inverse of 1. Okay, so cos inverse of 1 is 0. Right. Hold on. If the cos inverse is 0, then I'm arguing that the whole angle is going to be 0. Something is definitely not right. Oh yeah. Look at the mistake I made. I was assuming that from O to A is 12, but that is not 12, is it? No. From that to it's not 12. I'm not even going to use that. I can just use the arc length. Sorry, I waste your time, okay? It happens, even in the exam. So to find the theta is going to come from the arc length, and they gave us arc length to be 9.6, right? So r theta is the arc length, and that is 9.6. What is the radius? The radius is 12, so theta is just going to be 9.6 over 12, and that will be, this is something simple, and then it nearly had me. That's 0.8. Okay, now they want us to find the total area of the shaded region. Okay, so for this, if I can find the area of the triangle AOB, I can subtract the sector area from it and I'll get the shaded region. That is the plan I'm going to use, and I've been using this plan throughout here. Okay, but now I know that my angle here is 0.8. okay, so I can just put 0.8 here. Okay, so I said I'll find the area of the triangle first, which is let me just use symbol triangle area. Will be half. One thing is that I don't know. Okay, I don't know AO. I don't know that side. I don't know it. So I can't find the triangle right now, the area of the triangle right now. Let me go and find it. I think I can just extract this guy out here, what I was doing earlier. So this is A, this is O, this is M. I know this is 12. And then since I've taken half of the triangle, the angle here is 0.4, not 0.8, okay? So let me make it 0.4. I can find what is here by using cos, right? So cos 0.4 will be equal to adjacent, which is 12 over, let me use different color, over, let's call it AO. So AO will be equal to 12 over cos 0.4. All right, and that will be what? 12 over cos 0.4. That gives us, 13.03. Now I got 13.03. If I got anything which is less than or even equal to 12, I know I'm wrong. Even though this is not drawn to scale, I know that the answer I'm looking for should be something more than 12, right? Because AO is longer than OC. Keep that in mind. So now I can go back to my plan because I know AO. So triangle area will be half 13 point, let me just write 4 decimal places, 0285. Okay, and now remember that if this is 13.02 blah blah blah, this will also be 13.02 blah blah blah, because it is what? An isosceles. Okay, so 13.0285 times the angle, sine of the angle between them, which is sine 0.8. Quickly, let's put this on calculator. So we have 0.5 times answer times sine 0.8. That will give us 60.8822. Okay, hold on there. Then we can find the area of the sector. So sectorial area will be half r squared, right? But its area is its radius is 12. Okay, don't use the 13. 13 is for the triangle, 12 is the thing. So half 12 squared sine the theta, right? So that is let's see, 0.5 times 144, which is 12 squared, times 0.8, giving us 57.6. Okay, now what do? We subtract the sector from the area, the triangle. So shaded region will be equal to 60.8822 minus 57.6, giving us 60.8822 minus 57.6. That will give us 3 points. I'll just write 3.3 correct to this will be 2 decimal places, right? So let me just write it in 3 SF. Yeah, I think this is way better. Now what do they want? The perimeter of the shaded region. So that I think by now you've seen the clue. They can ask for you to find the angle, you can find the area, you can find perimeter. So these are the things that they are asking. This is why I call this series How to Ace the Exam, because if you know it, you know what to do even before you set the paper. Hey, by the way, all the best to those who are writing the November series. Okay, So we want to find the total perimeter of the shaded region. Okay, so that means that we already know the arc length, which is 9.6. All right, so all that we need to have is to know what happens with AB. Okay, if we know AB, then we can also know what the small value here, because this is 12, this is 13.02. So I think we can subtract and know what is happening here, what's happening here. So we add 1 to arc length 2 to here 3 to AB 4, and then we are done. How many marks did they give for that? 3 for all these problems. Okay, so AC and AD are the same, so that we can find that one quickly. So AC is equal to AD, that's equal to BD. So that's 13.0285 minus 12, okay? And that will give us 13. Is it not 1 point? Yeah, 1.0285. We don't need a calculator for this. Okay, then the next thing we know is that they also gave us arc length. Arc length is 9.6. Okay, they gave us arc length 9.6. So the real thing that we have to do is to find the value of AB. Okay, now to find the value of AB, you can use the triangle that we drew. Where is it? Did I clean it? Yeah, it's here. Okay, so we can use this triangle, okay, to find the value of AM and then multiply it by 2 to get the value of AB. So let's do that. This will be, if I want what is here, I can use, let me see, tan, right? Yeah. So tan 0.4 is going to be AM over 12, right? Good. So AM will be equal to 12 tan 0.4, which will give me 12 tan 0.4 will give me 5.0735. Okay, now I'm going to take all this and then go and put it down there to show working for what I'm doing. Okay, so I have this. Now this is AM. So if I want AB, then it's 2 times the value I have there. And that will be times 2. That is 10.1470. Okay, so I can now find the perimeter. All the pieces are there. So the perimeter is the arc length, which is 9.6, plus AB, which is 10.1470, plus this side, okay, and that side. So that we have already found to be this, but we are adding this thing twice, so I can just write plus 2 into bracket 1.0285, and that will give us, so that's 9.6 plus 10.1470 plus 2 into bracket 1.0285. And according to my calculator, it should get 21.8. Okay, and then you are good to go. All right, so now this is a little bit different. It looks interesting. At this point, let me see. I'll solve this question because we've done 44 minutes now. So I'll solve this question, and then because this question is similar to this one, so then I would probably solve. No, this is not difficult. This is also not difficult. Yeah, then I'll solve this. Okay, then we call it a day. Like I said from the beginning, I want to do it for just an hour. I don't want it to be too long. Solving maths for an hour isn't fun, is it? Yeah, anyways, let's do it, okay? Because we need the knowledge. All right, so what do we do? It says that the diagram shows the right angle triangle. Whoa, that is very, very important. So OAB is a right angle triangle. So the angle at A is 90 degrees. That is a cool chop. Once that has been established, we can do a lot of things. We can apply the trig ratios here. Okay, so keep that in mind. So the point C, we are told, lies on the line OB. Of course, we are not blind, we can see that. And then the angle OAB is pi on 2 radians. Of course, that is 90, we know that. And then the angle AOB, that's theta radians, they have shown that in the workout, which is cool. Then AC is the arc, of course, with radius 12. They have indicated that on there. And then the arc length is also 9.6. They want us to find the value of theta. Well, theta will be, we can use, since we know the arc length, it's easier to use the arc length formula. So that will be 9.6 will be equal to r theta, right? But what is the radius? 12. So we can just clean everything here and just write 12 theta is equal to 9.6. So theta is equal to 9.6 over 12, which will give us what? 9.6 over 12. That's 0.8. I think we saw one question and we got 0.8 as the angle. I remember. So this is 0.8. Great. Find the area of the shaded region. Well, area of the shaded region is area of the triangle minus area of the sector. You are done, okay? So let's start with area of the triangle. But I think there will be a problem because we don't know OB. We don't know this. We need that. Because we know this, so we can do half 12 times OB sine 0.8. So the only problem here is OB. That is what we need to find, and what can help us to find. Great, I just remembered. We are dealing with a right angle triangle. That is why it's cool, because you can extract this whole shape out, maybe like this, right? You draw it like that. Where the 90 degrees is A, so call that A easily. And then you have a 12 here that goes to O. The 12 is OA, so you can just call this O, and the other side is B, and that is what you don't know. And what you are looking for is the hypotenuse, actually. That is the OB, so you're looking for it here. Let's call that X. And also, you know the angle at AOB, so the angle right here is, let me use blue, is 0.8. So, you know, you can use, what trig ratio can we use? Hypotenuse, right? And we have adjacent, so we can use cos. So cos 0.8 is equal to, yay, welcome, cos, right, sorry for the disturbance. So cos 0.8 is equal to 12 over x. So x will be equal to 12 over 0.cos 0.8. Okay, so what does the calculator say? So we have 12 over cos 0.8, and that will be 17.2239, okay, something like that. So now we know what OB is. Okay, this is basically what our OB is. So we can find the area of the triangle. So triangle area, please don't go and write this in the exam as triangle area, just write the triangle in full, okay? This is YouTube. Cambridge is not going to penalize me, and no one is going to penalize me except you criticizing me in the session, the comment section. But after that, no real issue here. So, but I don't want you to do that. You'll be in trouble. So what you want to write is half 12 and then 17.2239 sine the angle, which is 0.8, and then put that on the calculator. So you have 0.5 times 12 times hold on, let me see my answer. Okay, good. 0.5 times 12 times my answer times sine 0.8. That gives me 74.13398, something like that. Then I need the area of the sector AOC. So sector area AOC will be equal to half r square. What is the radius? Radius is 12, so half 12 square theta 0.8, and that is 0.5 times 144 times 0.8. That is 57.6. So the shaded region, region, that is area. Okay, we are looking for area, will be equal to 74.13398 minus this guy, and then we are going to get 74.13398 minus 57.6, and that will be 16.53 SF. Okay, and then you are good to go. Right, so we have about 9 more minutes. Let's go and solve this particular question. Okay, so the rest that I skipped, of course you can solve it. I saw this question, I think that's 2020 paper. It was really cool, and I was like, whoa, there's very little information. So how will students solve it? That's why I really want to solve this particular question as the last question for today. Right, so how do we solve this particular question? Okay, so it says that the circles with centers C1, C2 have equal radii, okay, of R. And then C1, C2 is also a radius. So that means that C1, C2 is R. And then the circles intersect at A and B. So what do you, they gave you the perimeter, that is 4 pi, so find the value of R. Okay, now the first thing I want you to do is to draw a line from A, okay, all the way to B. Okay, then that means that this is half R and this is also half R, since C1, C2 is R. Okay, then the next thing I want you to do is to draw a line from A to C1 and then from C1 to B. Okay, now these are also going to be R because that is the radius. Okay, now do you know this one? Right, you do not know. So it doesn't matter, because this is going to be 90 degrees. Okay, now let me extract that part out. So if I extract, then what I do have here is R over 2 and then R, this is 90 degrees. Okay, now what can you do? Well, you can say that this, let's call this theta. Okay, and then you can find the value of theta. How do you do that? Well, you can use cos. So cos theta is going to be R over 2 divided by R. Okay, and that will be R over 2 times 1 over R, which will give you half. Okay, so you can just take the cos inverse of that. So theta is cos inverse of half. And our cos inverse of half will be what? Cos inverse of 0.5. That is pi on 3. Okay, so now you have your theta to be pi on 3. But you are not done, because if I take this triangle out, the C1, B, and A, I have to multiply my pi on 3 by 2 so that I will get the complete angle here. Okay, so let me call that angle beta. Okay, so beta will be equal to 2 pi on 3. Okay, now why am I doing this? Well, if I know the value of beta, then I can find the arc length right here. And if I know the arc length, then I can multiply it by 2 because the arc length over here is the same arc length over there. Then I can know the perimeter of these two arc lengths, and I'll equate it to 4 pi. Then I'll solve for r. So that's the plan. All right, so let's do it. So arc length would be equal to r times theta, right? 2 pi on 3, giving me 2 pi r over 3. Then I have to multiply this by 2 because, like I said earlier, this part is the same as that part, okay? So that would give me 4 pi r on 3. Now that is my perimeter of the shaded region. I can go and equate it to the one they gave me in the question. Okay, then I can say that this 4 pi will cancel this 4 pi. All right, that means that r over 3 is equal to 1, which implies that r is 3. Okay, or you can just cross multiply and then you solve for r and you also get 3. So you are done. Then the next thing that they want you to do is to find the exact shaded region. That means that do not round your answer. Leave it the way it is, exact. Okay, so if you want the exact shaded region, then what you can do is, okay, so now I'm going to, you can pause the video at this stage and then probably copy all the useful things that you want, because I'm going to clean the place up a little bit, okay? Because I want to do the analysis for you to see right there. You want the shaded region. Okay, how do you go about that? Okay, so why don't we know we have a lot of sectors here, and then we can also find the area of the sector, the area of the triangle, and subtract, and then we can multiply by 2. What I'm saying is that if I know the area of this sector AOB, this whole thing, okay, that would be great, because I can find the area of this triangle and subtract, so that I'll get only this portion. I'm going to highlight that. Oh, it's too big. Maybe in green, and then make that distance small. Okay, so I'm going to get the area of this green, and if I know the area of this green, I can just multiply it by 2, because it is the same as the area of probably, let me use this color, yeah, it's cool, because it's the same as the area of this place. Okay, so that is the thinking that I'm using right now. Okay, so now how do I find the area of that? So first I need the sector area. So area, let me use black. Sector area, sectorial area, which is AC1B, will be equal to r half r. I know r already to be 3, so half 3 square theta. Okay, but what is theta? We found theta, have we? Not yet, but I think we did. Did we not? Hold on. I thought we, oh, good. So I said that theta is going to be our beta to be 2 pi on 3. Good. So that is 2 pi on 3. Great. Okay, so what do we get? So that will be 0.5 times 9 times 2 pi on 3. So that gives us 3 pi. Okay, hold on. Then we can find the area of the triangle. So area, triangle, AC1B. That would be equal to half 3 square, all right, sine the angle, and the angle is 2 pi on 3. Okay, so that is 0.5 times 3 square, which is 9 times sine 2 pi on 3. And that, ladies and gentlemen, gives us 9√3/4. Like I said, do not use any decimal here. Okay, so the area, the green area is going to be, so I think we can copy all of this, right, and take it down there, because that is our workout. Okay, so we can say that area of segment, that's the green area of segment, is going to be the sector area minus the triangle over 4, right? Now the answer that we will get is the same for this place, so why don't we just multiply our answer by 2, the result, okay, by 2. So I can just copy this guy, shift it a little bit, and then do all this times 2. So if you like, then you can write as 6 pi minus pi 9√3 on 2. Okay, and this will be your final answer. Do not be quick to say that I'm going to use my calculator to simplify. Why? Because they said that leave it as the exact area, so don't touch it, leave it like that. Right, so this is where we end with our discussion on how to, ACE exam style questions on circular measure. I hope you have really benefited from this video, and if you have, please give me a thumbs up and suggest it to your friends and subscribe to the channel. That makes me happy. So I will link this particular worksheet in the description down there. Please download it and then give it a try, okay? Until we meet again, be safe. Bye for now.